In our last video, we learned how to take the determinant of a 2 by 2 matrix. Minus 2, minus 30. This determinant is minus 32. In this video, I want to learn how to take the determinant of the 3 by 3 matrix. And what we're going to learn is called cofactor expansion. And in Calc 3, we really need to learn how to expand this determinant across its top row. I'll discuss how to expand it over other rows and columns in this video, but we really need to know how to do this. So to expand a matrix, what you do is you pick a row or a column. And I'm going to write that A down. And now what I do is I multiply A by what we call the minor matrix that's left over when I take out the row and column where A are. So I need to take out the first row and the first column. And I'd be left with EF and HI. Minus B. And again, I take out the top row and now the second column because that's where B is. So I have DF and GI plus C. And now I take out the last column and the top row, DE and GH. And this we could take as our definition for the determinant of a 3 by 3 matrix. And what I've really done is I've rewritten this now in terms of the determinant of 2 by 2s, which I know how to take. We could go on and write this one step further where we write A times EI minus HF, but since we know how to compute the 2 by 2s, we'll just leave it right like that. Now usually at this point, if we were in class together, someone would ask, why is that one A minus? Well, if we were going to define the determinant using cofactor expansion, in front of A, B, and C, there would really be minus 1's raised to powers, determining whether it was a plus or a minus. And what you do is in that exponent, you add the row place to the column place. So A is in row 1, column 1. 1 plus 1 is 2 minus 1 squared is positive. For B, that's in the first row and the second column. 1 plus 2 is 3, minus 1 to the third is minus 1, so that's a minus. And then finally, we have 1 plus 3 is 4, minus 1 to the fourth is positive 1, so that's a plus. And that's how we could actually imagine doing this for any row or any column, always having that minus 1 in front. We'll do one example like that in a moment, but later on in the next video, we'll use exactly what I've written here to be able to take the cross product of two vectors in an efficient way. For now, let's take the determinant of a 3 by 3 matrix. So for our example, we'll use this matrix. On the top row, I have 1, 2, 3, 0, 4, 1 on the second row, and the bottom row, 1, minus 1, 0. Let's expand over that top row. So just following this pattern, I have 1 times, and then I need the determinant of this little minor matrix, right? Take out the top row, take out the first column, 4, 1, minus 1, 0, minus 2. All right, and then take out the top row in the second column, so 0, 1, 1, 0, plus 3. And again, take out the spots where 3 lives, and I have 0, 4, and 1, minus 1. All right, so here, let's see. Let's just take these determinants. 1 times 4 times 0 plus 1. It should be a minus time. It should be 4 times 0 minus a minus 1 times 1. All right, so that's going to give me a 1. So 1 times 1 is 1 equals, minus 2 times a minus 1. Take this determinant, you get 0, minus 1. You have a plus 2 there. And then finally, plus 3 times, that's a 0, minus 4. So I have 1 plus 2 is 3, plus minus 12 is minus 9. The determinant of this 3 by 3 matrix is minus 9. All right, well, that's the skill we need to be able to evaluate this 3 by 3 determinant using cofactor expansion across the top row. I'm going to take the determinant of this matrix two more ways. Once expanding over the second row, and once using a completely different technique, which just happens to work. Two notes I want to make before I do that. Cofactor expansion will actually take the determinant of any size matrix. Right? If this had been any size square matrix, if this had been a 4 by 4, this would look exactly the same, except for I'd have one more term down here, and the determinants wouldn't be little 2 by 2s, they'd be 3 by 3s. And then for each one of those, I'd have to do this. So the process gets longer and longer and longer, but still, this method will always work. And my second note is, if you remember in our video about 2 by 2 determinants and matrices, we're using the little 2 by 2 matrices to move points in the plane. You can use a 3 by 3 to move points in space. The determinant then isn't a scaling factor for area, it's a scaling factor for volume. Okay, but let's take this determinant two other ways. Okay, so I want to take this determinant of the same matrix, this time expanding over the second row. I'm going to label my rows and columns because I need to think about this plus and minus ones we talked about a minute ago. All right, so I'm going to start with this 0, which is in the second row in the first column. So that would have a little -1 to the 2 plus 1 is 3. So that would be an opposite of 0. Well, that's boring. That's still 0. But I'm going to write it down anyway because we're getting to know this skill times. And now I need to take out the second row and the first column. All right, and now I need to think about the next term where I'm going to have a 4. Well, it would have a -1 raised to the 2 plus 2 is 4, so that will be a +4 sitting there. And now I need to take out the middle row and the second column. 1, 3, 1, 0. And then finally, the last term would have a -1 raised to the 2 plus 3 is 5, -1. All right, now I take out the middle row and the last column. All right, well, this first part is super boring. 0 times anything is 0. And this is why sometimes when you're taking determinants, it might be nice to be able to expand over a different row or column. If something has a bunch of zeros in it, you want to use it. All right, so now I have 0 plus 4 times this determinant, which will be -3. -1 times this determinant, -1 minus 2 is -3. So I have -12 plus 3 is -9. And this makes me very happy because that's what we got when we expanded across the top row. Let's take the determinant of that 3 by 3 one more time, but not by cofactor expansion, using another trick that only works for 3 by 3 matrices. And that trick is to write down the first two columns beside the matrix. And what we're going to do is multiply down the main diagonals, the big long ones. And so what I'm going to do is multiply down and add the numbers I get. So 1 times 4 times 0 is 0. 2 times 1 times 1 is 2, and then plus 0. And now what I'm going to do is take away what I get when I multiply up the diagonals. 1 times 4 times 3 is 12. -1 times 1 times 1 is -1. And then I get a 0 there. All right, so let's see what happens. I have 2 -12 plus 1. 3 minus 12 is -9. This trick only works for 3 by 3 matrices, but it's a neat little trick.